So far, you have learned to solve definite integrals by the method of limit of sum and by second fundamental theorem on integral calculus. Now, let's learn the steps involved in the calculation of integral of f of x dx from a to b by the method of substitution with the help of an example. Let's evaluate step by step integral of 2x plus 3 into square root of 3 minus 2x into dx from 0 to 1 by the method of substitution. The first step to solve such integrals is to consider it without considering the given limits. So, we have integral of 2x plus 3 into square root of 3 minus 2x into dx. In the second step, substitute t is equal to f of x or x is equal to g of t to reduce the given integral to a known form. Here, to reduce the given integral into a known form, let us substitute 3 minus 2x as t square. This implies that 2x plus 3 is equal to 6 minus t square. Now, on differentiating both the sides, we get 2 into dx is equal to minus 2t into dt. This implies dx is equal to minus t into dt. Therefore, the given integral can be written as integral of 6 minus t square into square root of t square into minus t dt. This can be further be simplified as integral of t power 4 minus 6 into t square dt. Observe that here the new integrand is in terms of t. The next step is to integrate the new integrand with respect to the new variable without placing the constant of integration. So, on integrating this new integrand with respect to the new variable without mentioning the constant of integration, we get t raised to the power 5 divided by 5 minus 2t cube. Therefore, integral of 2x plus 3 into square root of 3 minus 2x into dx is equal to t raised to the power 5 divided by 5 minus 2t cube. Now the answer is in terms of t. So in the next step, write the answer in terms of the original variable x by resubstituting the new variable. On substituting the value of t, we get integral of 2x plus 3 into square root of 3 minus 2x into dx is equal to square root of 3 minus 2x raised to the power 5 divided by 5 minus 2 into square root of 3 minus 2x raised to the power 3. After obtaining the value of the integral without limits, evaluate this value at the given upper and lower limits. So, integral of 2x plus 3 into square root of 3 minus 2x into dx from 0 to 1 is equal to square root of 3 minus 2x whole power 5 divided by 5 minus 2 into square root of 3 minus 2x whole cube between the limits 0 and 1. In step 6, Subtract the value at the lower limit from the value of the upper limit to obtain the required definite integral. So, square root of 3 minus 2 into 1 raised to the power 5 divided by 5 minus 2 into square root of 3 minus 2 into 1 raised to the power 3 minus of square root of 3 minus 2 into 0 raised to the power 5 divided by 5 minus 2 into square root of 3 minus 2 into 0 raised to the power 3. On simplification, we get the value of the definite integral as minus 9 plus 21 into square root of 3 whole divided by 5. Hence, integral of 2x plus 3 into square root of 3 minus 2x into dx from 0 to 1 is equal to minus 9 plus 21 root 3 whole divided by 5. Let's now take a quick look at all the steps that we followed while solving the definite integral by the method of substitution. Let's see another example based on the method of substitution by changing the limits of the integration with respect to the new variable. Here, we'll evaluate integral of square root of x minus a divided by b minus x into dx from a to b. To evaluate this definite integral, substitute x is equal to a cos square theta plus b sin square theta. On differentiating both the sides, we get dx is equal to b minus a into sine 2 theta d theta. Now, x minus a is equal to a cos square theta plus b sin square theta minus a. On simplifying, we get b minus a into sine square theta. In a similar way, b minus x is equal to b minus a into cos square theta. Now, we will find the limits of the integral with respect to the new variable theta. When x is equal to a cos square theta plus b sin square theta is equal to a. On simplification, we get the value of theta as 0 degrees. Therefore, when x is equal to a, theta is equal to 0 degrees. In a similar way, when x equals b, a cos square theta plus b sin square theta is equal to b. So, on simplification, we get the value of theta as pi by 2. Therefore, when x equals b, theta is equal to pi by 2. Now, write the given integral in the new form as integral of square root of b minus a into sine square theta divided by b minus a into cos square theta into b minus a into sine 2 theta d theta from 0 to pi by 2. On simplifying, we get 2 times of b minus a into integral of sine square theta d theta from 0 to pi by 2. We know that sine square theta is equal to 1 minus cos 2 theta divided by 2. So the integral becomes as shown. On splitting the integral, we get b minus a into integral of d theta from 0 to pi by 2 minus integral of cos 2 theta d theta from 0 to pi by 2. We know that the integral of d theta is equal to theta, and that integral of cos 2 theta is equal to sine 2 theta divided by 2. So the integral will be equal to b minus a into theta between the limits 0 and pi by 2 minus sine 2 theta divided by 2 between the limits 0 and pi by 2. Now, on applying the limits and simplifying, we get b minus a into pi by 2. Hence, integral square root of x minus a divided by b minus x into dx from a to b is equal to b minus a into pi by 2. In this example, we followed the same steps with a small change in the fourth step. Hence, using these two methods, we can evaluate the given definite integral by the method of substitution.